making me eligible again.
And we're live! Alright, get out that packet. We're finishing it today.
I still don't have that packet.
Toby!
Oh, sorry. Carter. Carter's asking me to get it. Sorry, Carter. No, hey, I'll be nice. I'll give you half.
Put you in the air right now.
Yes. Whose mom is supporting Snack Club?
I buy my own stuff.
You're the mom? Quinn for mom. Quinn for mom. Quinn for mom.
She can marry Shelby and they can have
That's
a
right.
little Quinn
Shelby
and
will
Shelby
be dad.
baby.
Quinn will be mom.
Huh?
It's an election. Shelby's running for dad.
No,
Okay.
not right.
One nation, under God, indivisible, with liberty and justice for all.
We had to move last night this class.
I don't know what this is.
For you.
She's in college.
For you.
What the fuck is she doing? I know, she's not the group chat.
That's what it's about.
You know what it's about? Oh, okay.
That's for you.
For you.
What is this?
Yes.
I know, I read it. Stop! Okay, I'm calling you. Stop! Like sheep.
This is for you.
Am I still a failure?
I don't know. How are we judging this? This is for you.
Thank you. Kinda, I want you to drink.
Yes, you may. This is for you. This is for you.
Don't have to make it.
This is for you. Don't crumple that one.
I didn't get one back and now I'm scared.
Don't need one.
This is for you. All right. Oh no, she's back. For you. All right, we're gonna wait for Natalie.
Always seen it from me.
No, don't do it. It's for you. Don't throw it away. Hey, get it. All right. I need someone who's willing to film this. Who is willing to film this? All right, great.
Oh, I threw mine away. You're not supposed to throw it away.
All right, here we go. We're going to TikTok. All right. Yep. We're all going to Kobe into the bucket at the same time. All right.
Wait! But then we wouldn't make
I need someone to record this.
Yeah, I'll record it.
Mark is recording it.
I'm recording.
All right, get on your chairs.
Can I get on Macy's because I have no aim?
Yeah, that's fine.
Thank you.
I told you. Take respect. All right. Not making it in is exactly what we want to do here, probably. Because there's no way everyone's going to make it in. All right. I mean, we're just going to try the best we can.
I don't feel very safe in my Crocs.
Are you guys ready? Who's filming this?
Behind the back.
All right. Why are we filming it from the back? Film it from the
Wait,
front.
so we're not.
Yeah, do it in his chair. Yeah, do it in his chair.
Don't make it in. It'll be just like the
We almost died.
Yeah, play some good music for him.
Some good music.
Wait, how long?
60.
Try and do the best you can.
I'll
All
just
right.
do 60.
You guys ready?
We can always redo
Do
it.
it.
Are we recording?
Yes.
All right, on 3. We're gonna say Kobe on 3 and shoot.
Kobe.
No, just Kobe.
No.
Just say Kobe. It doesn't matter. Or a number. We want to say 1, 2, 3, Kobe. Okay. There we go. 1, 2, 3, Kobe.
Just like the dog talker.
That's all we want.
Sorry, Kobe.
I'm not
Kobe.
I'm not doing that.
All right, was that good or we need to do it again, Diana?
Yes. No, I don't want to do it.
Hey,
I'm not
kid, get
sitting
off
next
that.
to you.
What?
I know, but you have to do it right now. Tell her to do basketball. I want to do basketball. I'll do basketball. Yes. Wait, you're not even here.
I'm slipping.
Wait, well, no, I don't really want Miss
All right.
Graham. I love Miss Graham. People like literally like hate her, and I don't know how. I love her.
I don't like her.
Like, I feel like you either really, really, really like her, or you like absolutely hate her guts.
I guess I'm making.
No, I'm in the middle. Yeah.
Diana, make it
I don't like
good.
her
We want to be TikTok famous.
Okay, I'm posting it
yeah.
right now. I'll go live.
We got good music. We got good filters.
She deserves the world, and
Is it deep
and
fried?
her freaking dog, and
I only listen to deep fried.
what's her dog's name? Luna. I knew dog.
Deep fried.
She named it.
Oh, isn't there a flames filter?
She didn't know me until like 2 months ago.
Hello, class. Okay. So, yesterday, I believe we attempted number 9. Did we complete it?
Macy is here.
Weird. She looks smaller.
She's in the counselor, I think.
Oh.
Diana, what's your TikTok? Diana? What? What's your TikTok? No. Hold on. I'm 9 years. I gotta go edit it.
That's right. Take your time. We want to make sure it releases at the right time of day where everybody's seeing. Okay? And you want to make sure it's
he already
quality
knows.
stuff. Okay?
Well, that's at like 10 o'clock at night.
10 million.
See, like, you can't post it at 4:20. 4:20, yeah. I want to scream right now. Can I go outside and do it?
I wish we could do it in here without like having probably like Officer Dan run down the hallway.
Let's just do
But
it.
he probably will. Let's not.
I'll tell him to go
Trust
away.
me,
He knows
if
my
I could get
dad.
away with it, I would do that every day. Just
We're all gonna get
Don't
on
you have
camera.
sound panels?
We're not going
Those are
to.
expensive.
I will refrain from screaming.
My shoes are already dirty. Are you kidding me?
True or false? Did we do 9 yesterday or did we not?
We did 9.
We did.
Completely?
Yeah.
And I assigned 10 for homework, right?
No.
Okay. No, not at all? No. Alright, let's look at 10.
Thank you.
So here's the logic for 10. EG and BG are the same. EG, BG. We also know that AE and BD are the same. So that's these segments here. Lastly, and get ready for the squiggles,
Squiggies.
we know that C or BC and EF are the same. So this is going to take some squiggles to do. It's this, okay? And this. And it's weird because they overlap, I'm sorry.
Can we write stuff down?
Yes. And we're going to turn this in at the end of the week. Yep.
Unless you want to do it all on your own.
It's today. I don't know when it is. All I know is that I sent off the information to Landa. She's going to get back to me. I told her that Thursday this week would work really well, or Monday. But we can do it tomorrow. Tomorrow is a short class period, so that can.
Well, I went to the doctor last night because I've been having migraines, and they literally told me the reason I have migraines because of how much sodium.
All right, so given that information,
Because of how much
we're going to try and prove angle C and angle F to be the same angle. Now, those two angles belong to two triangles. Which triangles? Oh, only two, right? This triangle here and this triangle here.
So now I'm drinking.
So we need to prove those two triangles congruent, and then we can say by CCP their angles are the same, right? So how do we get this big triangle on the left and this big triangle on the right to be congruent? Right now we have a purple side and a purple side matching up. Notice the blue parts are only part of those triangles. They're not really going to be that useful, right? Same thing with this red bit right here. It's not the whole bottom of that triangle, right? Look at the big triangle. The whole bottom is this. So that alone is not enough to say side angle side or something, right? So we need to get this whole bottom, and we need to get some angles in here somewhere. So what do you see? What can we add onto this diagram? Katie.
Wait, okay, so could we do like the AEBD thing is like,
Say again?
okay, so with the, like AE is congruent to BD,
Mhm.
and then, wait,
Yeah.
and EG and BG are the same, so could we do something with like the, like subtracting property with that? 'Cause
Something like that. So what's going to happen is, see how these guys are bent, right? We have this going that way, right? So those aren't going to be the things we're going to do. What we're going to do is we're going to say this. I'm going to highlight this in orange so you can, actually not orange, so green so you can see it. It's not congruent to anything. I'm just marking it so you can see what I'm doing. So here's my logic. I'm not going to write this down, okay? Or I'm going to write it down, but you don't have to. We're going to cut to the chase in a second. So AE and EB, when I add those together, what I get is AB, right? AB is this big segment down here. Everybody see that? And that's the bottom of one of our triangles. Is everybody cool with that idea? I haven't given a color to AB because I haven't proven anything's congruent to it yet. But I'm going to use that same logic to say that BD, the other red part, plus the same green part, EB, must add up to ED. Again, I haven't given it a color yet because I haven't said it's congruent to anything. That's my logic. Is everybody cool with that? That's segment addition postulate. The two little pieces add up to the big piece. The two little pieces add up to the big piece. You with me? Now notice that these two red pieces are congruent, right? That's why they're both red. And the green is the same for both. So we have red and green makes AB, and red and green makes ED. So shouldn't that mean AB and ED are the same length? Right? So that's going to be my logic. Therefore, AB equals ED. So, how am I going to cut to the chase? I don't have to write that on my quiz. I can just say, by segment addition postulate, yada, 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 I know that AB and ED are congruent. So, Katie, not exactly what you're saying, but good eye. There was something we can do there. Yeah. What we're going to do either tomorrow or on, no, tomorrow's Wednesday. Yeah, we'll do it tomorrow. Tomorrow, we're going to play a game of spot the thing. So I'm going to give you a bunch of diagrams, and we're not going to do the whole proof. I'm just going to say, there's segment addition postulate here, where can we use it? And I want to get you guys used to finding those things. And we'll flip through them back quickly. That way you'll get used to looking for the signs, right? I think that'll be useful. All right, so we've got that. So now we have purple side and black side. Both of those are congruent. So if we can get another angle in there, we're good. Or we get these last sides congruent, we're good. Spoilers, you're not going to be able to prove those last sides are congruent until after you've proven the triangles are congruent. So that's just not going to be it. We need an angle somewhere. Katie, what do you see?
the theorem, like not the converse. For,
The regular theorem. Mhm.
Yeah, because those for EG and BG.
Yep. These are congruent, so right here is an isosceles triangle. So that means these angles are congruent. Nice job, Katie. Like Australia, you're on fire. So by isosceles triangle theorem, we know that angle GEB is congruent to angle GBE. Cool. So now what do we have? We have purple side, blue angle, and then black side. So side angle side, right? We have that for both triangles. So now we can say the two big triangles are congruent. So I'm going to zoom out so you can see what I'm talking about. I've got purple side, blue angle, and this black side down here. Side, angle, side for that big triangle, right? Again, ignore this line here and that angle. Side, angle, side for this triangle. Pretty Cool with that? So by side angle side, triangle ABC is congruent to. Well, angle A is made up of the unknown side and then the black side. Over here, unknown side and black side makes up angle D, right? So A and D are going to go together. B is made up of black side and purple side. So if I go to the other triangle and look up the black side and the purple side, I get angle E. So B and E go together. And then C is made up of unknown side and purple side, right? So if I go to the other triangle, unknown side and purple side, I get angle F. So ABC and DEF go together. It's important to get your letters right, because the next thing we're going to say is by CCP, we know angle C and angle F are congruent. Why? Because look, angle C and angle F are corresponding, right? So by corresponding congruent parts, angle C is congruent to angle F. We're done. How do you feel? Decent? We're going to back up and go over it again. So, by segment addition postulate, A, B, and EB are the same. This is definitely the hardest part to understand and to see. Okay? This segment here, the bottom of this triangle, right? Does everybody see the big triangle? Right? Bottom of that triangle is the same as the bottom of this triangle. How do we know that? Because red and green is what makes up this bottom, and red and green makes up this bottom. So they must be the same. That's segment addition postulate. The pieces make up the whole. Everybody cool with that? That's great. Next, by Isosceles Triangle theorem, we're given two sides congruent, so we know two angles are congruent. Feeling good? All right. By side angle side, we know that purple side, that blue angle, and this black side, this whole thing down here, the red and green side, right? We've got side angle side for both triangles. So those triangles are congruent, and then since we matched up the letters, we can use CCP to say that C and F are the same, because they correspond. Correspond means same relative position, right? C and F are both in the third position. So those angles are congruent, that's what they wanted, we win. How you feel? Decent? Right. Let's put that away. Let's actually, well, not put it away. Let's get out same packet but different numbers. Let's do an easy one and then not so easy one. Number 8. 8's the easy one. Okay, so this is coordinate geometry. Coordinate geometry is basically cheater geometry. Regular geometry is like, it's not drawn to scale, you can't measure it, right? Doesn't look like a right triangle? Haha, it is, right? That's regular geometry. You hate regular geometry because it's like that. Coordinate geometry is like, you can measure, everything's drawn to scale. So how do we prove something that's isosceles? Well, we measure the sides and see if two match up. Now, how do we measure on a coordinate plane? Distance formula, right? Which is the same thing as p-theta. So if I were to give you this in regular geometry and I'd say, prove that that's equilateral, you'd go, well, I can't because we can't assume it's drawn to scale, right? But if I said in real life, prove it's equilateral, well, you could go, oh, okay, well, it looks like about 3 inches there, so 3 inches there, and on the other side, if it's 3 inches, then oh, it's equilateral, right? And you call it a day, right? So what we're going to do with coordinate geometry is we're going to just measure it. That's it. We're just going to measure the triangle, and if it's two sides it's the same, then this is stupid. Why do I show you this? Because if I don't show you it, you'll never figure it out on your own, probably. Some of you might, right? But in general, this is the stuff they put on like tests that you might take, like the ACT, etc., to test geometry. Because real geometry, we know, takes actual thinking and understanding and concepts, and can't just be, hey, is it isosceles or is it not? You have to have an explanation right behind it, using different theorems. And they're like, how do we test that? I don't know. And so what they do is they put this on there and they call it geometry. So I want you to be able to see it so you know what you're doing. Because unfortunately these tests matter. But in general, you're way smarter than it. What this really tests is, do you know what isosceles means? And the only way you know what that means is if someone told you. Right? So kid that doesn't know what it means versus kid that does is the difference between I took the class versus I didn't. So it's not really showing who's smarter, right? Just who was told that that's what the definition is, right? And it's also testing to see whether you can figure out how to measure these line segments, right? Which we know how to do. So we're going to say A is at 7, -1, over here by my mouse, and B is in 2, -2. They tell us C is 3, 3. And if you have 3 points, there's only one way to connect them and make a triangle. Miss Sandra, I'm so happy to see you.
Yeah.
All right, crumble it up, Kobe it. All right. You missed our TikTok that we made earlier. You can watch it on Diana's TikTok. Diana, you wanna plug your stuff? What's your TikTok?
Go right on the board.
What's your handle? I assume it's a handle like Twitter. I don't know, TikTok. An at, so it's a handle, yeah.
You should use a prettier color than green.
But Mr. Mac, do you have TikTok?
No.
You should get it then.
No.
Miss Palmer has it. I just haven't found it.
Yeah, but like Miss Palmer and I are separated by quite a few years, I would assume. Also, I'm not interested in seeing like young high school and middle school kids do cringy things.
Mr. Mac, if you get Snapchat, I can send you all the good
Yeah,
Like
get
Asian.
Snapchat. I'll ask you.
I'm at least 50. All right.
No, I don't.
That's not even you.
All right. So add Diana.Robbins12.
Yeah.
She like actually helps.
Oh,
Go to her TikTok, and you will see our
Tell you
TikToks.
about the Cheeto.
I love how everything's called TikTok. Like imagine if Twitter, everything was called Twitter. I just sent out a Twitter on Twitter, right? What's your Twitter? Can I Twitter your Twitter? Yeah, no. How about no?
She's not a good counselor. I miss Churchill so much.
Twitter used to be a garbage website, and now it's more like for professionals.
Did you get like her? She's the best person in the entire world.
Nope, this is just number
She's
8.
better than any teacher except my
You need number 8.
Max.
Or did you find it?
Oh my god.
All right, I have distracted you long enough that Macy has found number 8, and so we are ready to go. You thought I was just being goofy, but I wasn't. I did it on purpose. All right, so. Hi. Here's how we're going to tell if these work. We can plug in those coordinates into the distance formula, right? The x2 minus x1 all parentheses squared thing, right? Basically p-tag, right? Or, since we have a picture, let's just make right triangles, right? So I'm going to do this. I'm going to connect C and B by using a right triangle. And notice that we can easily count the squares if we do vertical and horizontal lines, right? So that's 5 and 1.
I stand by that.
So BC is going to equal the root of the square of those sides. Does everybody follow me here?
Yeah.
Right? The distance between C and B is going to be the hypotenuse. And to find the hypotenuse, I just do a squared plus b squared, right? And then root. So what I get is root 26, because 5 squared is 25 and 1 squared is 1. We add them together, we get root 26. Now, I could also connect C and A in a right triangle, but if I do that, do I get the same kind of right triangle? No, I get a 4 by 4, right? So why even bother? It's not going to be the same, right? So B to A, though, if I connect them, you'll notice I've got 5 here and 1 there. So yeah, they're going to be congruent, right? So AB is also going to be root 26. Because we have 5 squared and 1 squared. That as well. So therefore, let's say by p-thag. How about that? P-T-H-A-G. By p-thag. Therefore, AB is congruent. Oops. To BC. And then we say, by definition, if 2 sides are the same, right? Then it's isosceles. So by def, triangle ABC is isosceles. Yes? Yes, you may. How do you feel about that one? Okay? If I want you to prove a triangle is equilateral, you do it for all 3 sides, and if all 3 sides match, and you say, by definition, that's an equilateral triangle. Bum, ba-dum, ba-dum, bum, bum.
I need a worksheet from you. No, I need the triangles, A side English.
Oh, okay.
You should probably mark
That's not
it as
English.
TikTok, because people might think that's kind of stupid.
Or Twitter.
What is irrelevant?
And then there's the kids who still use Facebook. Yikes.
I made a Facebook account like a week ago, but that's because I wanted to see if my mom had embarrassing pictures of me that kids from the school could find, and she does.
I only have it because my
What's
parents
your mom's name?
I don't know.
I don't know.
You know what's
I forgot.
whenever there's like a presenter, like a speaker or something,
I
and
know
they bring up
spell.
social media, they're always like, oh, you know, people use like Facebook, Twitter, and it's like, you know,
No, they don't.
Aw, bro.
maybe sometimes they'll say
Yes.
Instagram.
All right, that's 8. Now let's do a harder one. Let's do number 7.
Somebody's calling me.
Before we do 7, I'm going to take you on a magical journey, a blast from the past, if you will. All right, here we go. Follow me on a magical journey to last semester. A semester of which none of you want to repeat.
No.
Oh,
I actually kind of want to go back to like the first semester. Yeah, she likes to keep her Facebook very private, so people can't see me. She will not add you back. She'll add me back. I even have my mom.
You said it in front of the class.
Oh my god.
And then you all go like this. Oh my god, I have a friend who does
My mom, but she won't even add me back.
What? I guess this is.
Probably because she doesn't like her.
Transversal.
I'm her child.
Yep, that's right.
You're playing.
Make it quick. All right, so last semester we learned that if L is parallel to M, then what is true? Ladies, I need you back. If L is parallel to M, then what is true? Well, transversal is any line that crosses two others, so it doesn't matter whether they're parallel or not. What's going to be true? What will be true?
Lines with the same angles.
Something with the same angles? Yes. What angles will be the same? Corresponding angles will be congruent. Nailed it. So if L is parallel to M, then corresponding angles will be congruent, like the ones I just labeled. Remember, corresponding angles are angles that are in the same relative position. And this is one of our theorems or postulates. Does anybody remember what postulate this is? What is this? That was gross. What postulate is this that we learned last semester? If the lines are parallel, then these guys are congruent. Anybody? Cap, thank you very much, Macy. Corresponding angles postulate.
Yeah.
Now, the question is, I said some theorems, converses are true, some are not, right? Some don't work forward and backwards. This one does, actually. If we know that the corresponding angles are congruent, if we're given this, then we do know that L and M are parallel. It does go both ways. So the converse of that would be written like this. If corresponding angles are congruent,
Is this just like a random one you need?
then, what do you mean? So this is corresponding angles postulate as well, but in reverse. So we're going to call it corresponding angles postulate converse. So if we need to prove two lines parallel, we'll use the converse of cap. If these two are parallel, or I'm sorry, if these two are the same angle, then these must be parallel lines. We'll be using that. We won't be using that exactly for number 7, but that's your hint. Everybody good with this, both forward and backwards being true. If we're given the lines are parallel, then we get this, right? Corresponding angles postulate. If we're given the corresponding angles are congruent, then we can conclude that the lines must be parallel. The converse also works. You cool with that? All right, rad. So let's look at number 7. This is a tough one. We've had 2 classes in a row where someone had a big brain play, 2 big brain plays to get it done. Let's start out with the basics. They tell us that ARB and TSC, that they're parallel and that they're lines, right? That symbol on top means they're line segments. The symbol there means they're parallel. So if they're parallel, let's make a little parallel symbol. Remember, that's the big arrow, and it goes to both way, the same way for both. So those are parallel. It tells us that RT bisects angle BRS. Okay, so follow me on this one. Angle BRS is this angle, BRS. It's this angle right here, this big angle, okay? And RT bisects it. Remember, bisect means to cut into 2 equal pieces. Ladies, put it away, because you're going to get lost and it's going to waste my time later, okay? So BRS is this angle, and RT bisects it is what that says, right? So that means that RT, this segment right here, is cutting this big angle into 2 equal pieces. So what that means is this. This angle and this angle must be the same. Does that make sense? Bisect means to cut into 2 equal pieces. So we've got this guy cutting the big angle into 2 equal pieces. Then we know that M is the midpoint. Let's get, where am I at that point? M is the midpoint of RT. Here's RT. M is its midpoint, which means that we have a congruent segment here and a congruent segment there, right? Midpoint means to cut in half as well, right? You could, another way you could say that is SM is bisecting RT, right? It's cutting into 2 equal pieces. And that's all the information they give us. They want to know, does SM, this middle line right here, does it bisect RST? And if so, can we prove it, right? So we're going to prove that RST, this angle right here, is cut into 2 equal pieces, right? And then by definition, it does, right? It does bisect it. So we're going to prove that this angle and this angle are the same. And then we win, right? So that angle belongs to a triangle. This triangle, the top triangle, right? And that angle belongs to the bottom triangle. So if we can prove those 2 triangles congruent, then we can say their angles are congruent by CCP, and then we win. So how do we prove these 2 triangles congruent? Right now, all we have to prove them congruent is one angle and then matching sides. We don't even have the matching angle down here, right? So we need more information. How can we get it? What more information can we get and how do we go about it? What do you see? What do you see? Take your time. Use this time to practice looking for things. How can we get things to match between the 2 triangles? What do you see?
Nellie thinks it's shared side.
We have a shared side right here, right? This side is shared by both triangles, right? So we can say by shared side, SM is congruent to itself. Good start. Well, this one, we've got 2 sides and an angle, but we only have the 2 sides over here, so we're going to need more. What else can we get? This is tough. I'll give you a hint. You're going to have to think outside of the diagram a little bit.
No, I don't know.
Okay.
Wait, if you extended the lines, would it basically just be?
What lines am I extending, McKenna?
Wait, if you extended, wouldn't it be CT a little more and then?
CT, so extend it out this way?
Yeah, and then RT, wouldn't it be a 2 parallel lines cut by a transversal?
That's right. McKenna's got the big brain play. Well done. Check it out, guys. If we extend those lines, we have 2 parallels cut by a transversal. Now, in order to do that, we are creating something. Before we just did it on our diagrams and call it a day, right? We need to talk about why that happened. So we're using the create a line thing, right? Let there be line. But we're really going to do it this way. So in order to extend those lines, they have to extend to something. So we're going to extend them into these points. Let's call them something. First hour, called them JKL, so I've been calling them JKL all day. So, McKenna with the big brain play. How do we make that happen down here, right? We're going to say, let there be. Okay? And we're going to say, let there be a line. So we're going to use this line segment symbol. And we're going to call it segment S or CSTJ. Sorry, I covered up T. T is here. So all of that is one continuous line, okay? And we created another line. LRMTK. So we're saying that all of that is one giant line. They were lines before, so when we add on the points, we can just extend those, right? That's fine. This is using the let there be line postulate, right? So now that we have that, McKenna, what do you see that we can do?
We do cap.
We can. This angle right here and this angle down here are corresponding, right? And so by cap, they're the same. I'm going to call it angle BRM, and the other angle I'm going to call it JTK. Enough, Quinn. Is everybody cool with that? Now, great, but that angle isn't even part of our two triangles. So what does that get us? I'll say it again. That angle we just got, not even part of our two triangles. So what does that get us? Nothing yet. Katie.
Linear pair theorem.
What do you mean?
Like we can take those and make it so it's 180.
These two right here?
Yeah.
Yep. So we know that this and this is going to add to 180. That's true, but again, that's not part of our triangle. Neither is this for a linear pair. You're onto something.
Vertical.
You're close. Vertical. Katie, what really is the key is that these two are going to match, right? Which means these two will as well, right? So you're onto something there, Katie. Vertical angles are going to be the same. So by vertical angles, VAT. We know that angle JTK, that angle that we found before, is going to be congruent to angle MTS. Rad. Okay, so now look what we have. We have two angles, right? A pair of angles. We have a pair of sides and a pair of shared sides, right? So we have a problem. We've got ass. Are these right triangles? Not that we know. In fact, you can't prove that they're right triangles until we learn a new theorem, and that theorem requires you to know what these two angles are. So we're never going to be able to prove them right triangles in this proof, okay? So we need other information. We can't use ASS because they're not right triangles. So who's going to have the next big brain play? Don't be afraid to take a shot. Toby wasn't. What do you see? What do you see?
Isosceles.
Where? What triangle?
The triangle.
Is it?
Let him finish and then we'll see. McKenna sees it.
The whole triangle.
What triangle am I looking at? Give me letters.
RST.
Yep, RST is isosceles. Do you see the big picture? These two angles are the same, so this triangle must be isosceles. The big picture. You see it now? Nice job, McKenna. Which means these two sides must be the same. Did we use the theorem or the converse? Converse, we started with the angles. By isosceles triangle theorem converse, we know that triangle, let's call it RST, like Carter said. Oh, no, sorry. Don't call it RST. Let's talk about the segments. RS congruent to ST. Right, those two segments are the same, those two red segments. Sorry, I didn't do it in red. I've been using a lot of red. All right, so now do we have enough to prove those two smaller triangles congruent? This triangle and this triangle. Yep, we've got a lot of information. In fact, we can do side angle side, or we can do side, side, side. Let's do side, side, side. Doesn't matter. But let's do side, 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 just so we use that shared side from Nelly. Respect. by
Can you like?
side, side, side. Yeah, let me zoom out. Sorry. By side, side, side. Triangle RSM is congruent to. All right, so R is made up of the red side and the green side. So if I go to the other triangle, red side and green side will be T. S is made of red and blue. So I go over here, red and blue is also S, so S goes with S. M is made up of green and blue. Green and blue over here also makes up M, so M goes with M. RSM equals TSM. They're congruent. Now again, our goal was to prove that SM is bisecting this big angle, right? Well, if the triangles are the same, aren't their angles the same? Their parts will be. So we're going to say this angle and this angle are the same. How? By CCP. Angle RSM is congruent to angle TSM. How do I know that's true? Look, RSM, TSM. Their parts correspond, right? Now, could you have written it weirdly? Sure, you could have, right? If you wrote MSR down here, you could have done it backwards. You could have done it whatever, right? You could have written your triangles differently than I did. That's fine. Just make sure they match up. See how it's first, second, third in that order, right? First, second, third in the same order. So those angles will be congruent by CCP. You with me on that? If those two angles are congruent, does SM bisect RST? If those two angles are congruent, does SM bisect RST, the angle? It does, right? By definition. So by definition, that's an angle bisector. SM bisects angle RST. Sorry, angle RST. We're done. We're going to back up and go over it again. Yeah. All right, here we go. Here was our logic. Shared side. Everybody see it? I think we played spot the shared side game. I think most of you guys would be pretty good at it, right? Boom. Those two triangles share a side. Next, we extended our lines out. We said let there be these lines. We labeled some new points, right? Call them whatever you want. Is everybody cool with that idea? That you can extend the lines? We've always done it. We're just calling it out now. My cap then, these two angles are the same because those two lines are parallel. We have a transversal cutting two parallel lines, so those two are the same. Corresponding angles possible. By vertical angles, these are the same. There we are. Then we said by isosceles triangle theorem converse, these two are the same. Because if those two angles are the same, then this triangle is isosceles. You with me? Okay. Then by SSS, this and this are the same, these two triangles. Then by CCP, their parts are the same because they line up. First, second, third, right? And then we can say, if those angles are the same, then this must be bisecting the big angle. So this bit right here must be cutting this angle into two equal halves, right? By definition it does, so it's a bisector. How do you feel about this? This is a tough one. Seeing the extension was a big brain play. Seeing the big triangle afterwards, Carver, right, was a big brain play. How do you feel? Tomorrow, what we're going to do is, again, get a bunch of diagrams, and we're not going to prove them, because that takes a long time. What we're going to do is spot the thing, right? So I'll say, in this diagram, there's an opportunity to use isosceles triangle theorem. Where is it? And you'll point it out. And I'll say, great, next diagram. There's an opportunity to use vertical angles. Where are they? Right? And I want you to get used to spotting these things. We're going to figure out what you're good at spotting and what you're not good at spotting, and then we're going to practice more what you're not good at spotting. And know that when you're screwed up, you're like, man, I can't see anything. What are the things I always never see? Well, I never end up seeing linear pairs here. All right, so I should start looking for that, right? Give yourself direction. Know what your tendencies are. Know thyself. That is our goal for tomorrow. If I can tell Landez to get the pizza here for tomorrow, I will. I'll send her an email now. If not, we'll either have it Thursday or Monday, or whenever she decides that we're able to have. I don't know. Those are the days I gave her. We'll see what works for her.
Can I tell you my story now?
Yep, go.
Okay, so last night, so I got my permit yesterday.
Yep.
And